All right, so section P4 is polynomials, and this screen is just giving you some basic information. So first of all, in that gray box, that's what a polynomial's like technical definition is. So it's just a string of terms added together. You're going to have some special rules about polynomials, though. We want to make sure that our coefficients are real numbers. We need our exponents to be positive. We need them to be rational, so no fraction exponents, no negative exponents. Polynomials are just nice, well-behaved functions, like you can see underneath the box where I give you a couple of examples. So here we have 1, 2, 3 terms. The one without the variable is the constant term. The one with the biggest exponent is going to be the leading term, because in order for you to end a problem with polynomials, they're always going to want standard form, which means they want the biggest exponent first. So your leading term is always going to be the one with the biggest exponent. So if I take this one and I write it in standard form, the 5x to the 8th becomes my leading term. And then my constant would be 10 over here. So again, the rules in this yellow box, for it to be a polynomial, we have to have whole number exponents. That means no fractions, no negatives. We have to have no variables in the denominator, and we have to have real number coefficients. And then standard form is put your biggest exponent first, and then go from there, getting smaller as you go. All right, so these are not really things that you have to know. I just need, when I use the words in the future, I need you to know what they mean. So a monomial is one term, a binomial is two terms, a trinomial is three terms, and then a constant function or constant degree is degree 0. A linear function has degree 1, quadratic is degree 2. Remember, degree is the biggest exponent. So cubic would be degree 3, or the biggest exponent is 3. Quartic would be degree 4, or the biggest exponent is 4. All right. They keep going. You can have quintic, and they keep going, but as far as we're concerned, I probably won't say anything more than quartic. I may not even say anything more than cubic, but we'll talk about functions later, and I just wanted to make sure that you remembered that you had learned these terms and that you knew monomial, binomial, trinomial. All right, so the basic idea of what's going to be happening in this lesson is we're going to add, subtract, multiply polynomials, and then we're going to have to do some work with some radicals that's pretty similar. So with addition, you're just adding like terms. So 9x to the 5th does not have a friend. 6x to the 4th does not have anything to add to. You have negative 7x to the 3rd and 9x to the 3rd that you can combine, and then you have your x. For number 2, we're subtracting. So remember, that means add the opposites. So you can show it like that, or you can just rewrite the whole problem and make this minus 4x squared plus x. I don't care which one of these you do, but you have to show one or the other. And then again, you're combining like things. So negative 8x to the 3rd minus 4x squared, and then you can combine these and get 5x minus 1. Here, same thing. Think of this as plus the opposite, so these both become negative. Or rewrite the whole problem. As long as you show it one way or the other, you're good on a test, but you have to show one or the other. Then let's see, we can combine the x squared y's, and that would be 4 minus 3, so one of them. And then your 7xy, and then you can combine the negative 2 and negative 8 and have negative 10. All right, so when you're multiplying, when there's no plus or minus between a term and the parentheses or between the parentheses, you know you're multiplying, and you're going to multiply coefficients and add exponents. Multiply the big numbers, add the little numbers, however you want to think about it. So this would be 20y to the 5th This would be negative 12y to the fourth, and then 28y to the third. So you're using that distributive property. All right, so when we get to problems like this, you may have learned FOIL at some point, but most of the time we just teach distribute in high school. But here's what we're doing. If you, in Math Excel, they'll sometimes use FOIL, which is first, outside, inside, last. So multiply the fronts, multiply the outsides, multiply the insides, multiply the backs. That's what FOIL stands for, first, outside, inside, last, if you see that in Math Excel. But we just like to think of distribute this to both and then distribute this to both. That's what's really happening. So here we get 15x to the fifth. Here we get 27x to the third. Here we get negative 35x squared, and then negative 63. And then you may or may not have like terms. In this one we do not, so we are done. Number 6, though, I believe that we're going to get some like terms. So 15x squared plus 35x minus 24x minus 56. And then you do have some like terms in the middle. So we'll get 15x squared plus 11x minus 56. All right, so you've done this quite a bit in the past, so I would say pause and do 7 through 10 and then go back and see if you agree with me and then what like things I point out along the way. All right, so number 7, if you look at these are called conjugates because they're identical except for the sign in the middle. That's going to become important on the next slide. If you have conjugates, then you should be able to just do the fronts and the last because the middle is always going to cancel out. So I'm going to do the long way. I'll do all of it and show you what I mean. So we get 64x to the fourth minus 40x squared plus 40x squared minus 25 when we do all of our distributing. And then these middle terms, those are always going to cancel out when you are multiplying conjugates. So if you realize you have conjugates, then you can just do front times front and back times back and get your answer without extra work. All right, number 8, there's also a shortcut to it. However, on your test, they specifically want to see all of the steps. They don't want you to use the shortcut. So make sure you understand that this is the same thing as this. So if they give it to you like this on a test, they want you to write it out like this. And then you're just going to do your distributing. So you would get 9x squared plus 6x plus another 6x plus 4. So you'd have 9x squared plus 12x plus 4. Now, if you're working in Math Excel and you remember the shortcut from Algebra 2 and you want to use it, you're welcome to. Just remember on a test, they want to see you write this out twice. They want to see this step and they want to see this step. They don't let you skip anything. All right. Number 9, let's see, we're going to do 2x to the third. And then we'll do minus 6x squared and plus 12x. And then it's negative 5's turn, so negative 5x squared plus 15x and minus 30. Then go back and we can combine our x squareds and our x's. And we're done. All right, number 10. Let me switch colors because I'm going to have to squish them kind of together. All right, so this would be, what, 18x to the third, y to the second. This would be negative 72x squared y. This would be 45xy squared. Then we come back and do it again with the 5y, so 10x squared y squared. and then minus 40xy and plus 25y squared, and I don't see any like terms. In order for them to be like terms, everything would have to match. Was it supposed to be a square and my pen just didn't write? No, I don't know what that little dot is for. Let's erase it. This should not be there. That was a big eraser. That should not be there. Okay. All right, so again, no like terms. We're done with that one. All right, so for P4, that's the most of what you're going to do, but they are going to have you do some with radicals. So same things that we were just doing, but you have radicals. So you're going to have to use your P3 knowledge with your distributing knowledge. So we would do 5 times 4 and get 20. We do 5 times negative 3 root 2 and get negative 15 root 2. Root 2 times 4 is 4 root 2. Root 2 times negative 3 root 2 is negative 3 root 4. All right, on a tech test, you may want to take your time showing your work. For me on Math Excel, I'm okay if you look at this and say this is really negative 3 times 2, so negative 6. So if I put this negative 6 with this 20, that's 14. And then I can combine these. It's negative 11 root 2. So this is my final answer. Number 12, if I multiply here, I get 8 root 36. Then we get negative 2 root 18. Then this is negative 4 root 18. And this is positive root 9. All right, I'm going to work this one out with showing all of the work and going the long way. Let me plug my computer in. Okay. All right, so then this is 8. Sorry about all that. This is 8 times 6. We can break this into 9 times 2. Same thing here. This is just 3. So then this would be, what is that, 48? And then pull a 3 out here. So this would be 2 times 3. So that'd be 6 root 2. Pull a 3 out here. That'd be 3 times 4. So that'd be 12 root 2. And then now we're going to combine our like terms. So 48 and 3, putting our constants together, and then putting our root 2's together, we get negative 18 of those. All right. 13. We again have conjugates. Did I just say conjugates up here? I think I did. I don't know what I was saying. Putting our radicals together, our root 2's. If I didn't say that, then I apologize. Ignore whatever. My brain is not functioning properly, apparently. All right, so here we have conjugates because we have the same thing except the sign in the middle. So we can just say, I know this is going to be root 4, and I know this is going to be negative 25. So 2 minus 25 gives me negative 23. All right, here, remember that they want to see all of this written out. So they want to see that you wrote this out like it's times itself, and then do all of the math. So if we do this times this, we get 4 root 25. Then here we would get plus 4 root 5. Here we get another 4 root 5. And here we just get 4. So this is 4 times 5, or 20. So add that to the 4 and you get 24. And then combine these and you get 8 root 5. So again, as long as you're showing what's happening some form or fashion, this should be fine on a tech test. Showing it completely all out like I did up here on 12 is also acceptable. That's probably what they would prefer. Number 13, if you want to go ahead and show all of it and the ones that cancel out, you can, or you can write that these are conjugates. and just do the shortcuts. All right, so these last few, if we are dividing radicals, which is what's happening here, we have to rationalize the denominator, which we did a little bit of in a previous lesson. So for this one, this shouldn't be too foreign to you. If we're going to rationalize the denominator here, then what's going to happen is we just need to multiply by root 6. So we do that on top. So on bottom, you get the square root of 36, or just 6. The numerator, though, this is distributing, so you're going to get the square root of 12 plus the square root of 18. So again, break this down, 4 times 3, break this down, 9 times 2. You always have to simplify even if nothing comes of it. So if we look at this, we're going to get 2 root 3 plus 3 root 2 over 6. And there's nothing you can do at that point, but they do want to see that it has been simplified. You can't leave that root 12 and root 18. All right, so here is what should not be news to you because you did it in Algebra 2, but we haven't done it so far in this class. If we multiply by the conjugate, then we will get rid of the radical. So if you think about the last, what is that, number 13 up there, where we multiplied conjugates, that radical went away. That always happens. If you multiply conjugates, your radical always goes away. So that's how you rationalize a denominator with more than one term. Multiply by the conjugate. We'll do that to the top and the bottom. So then 7 multiplies on top by 3 and by root 5. And then on bottom, you can just do front times front, back times back, and we know that's root 25 or just 5. So then we would get 21 plus 7 root 5 over 4, and you are done. All right, number 17, we're going to multiply by root 5 minus 2 on top and bottom, because that's the conjugate of root 5 plus 2. So again, distributing this, we get the square root of 75, and then that's not plus, that's minus. 2 root 15. And then on bottom, we get the square root of 25, so 5, and a minus 2. All right, so we got to do some simplifying here. We've got to call this 25 times 3 instead of 75. 15 doesn't have a perfect square factor, so it's just going to stay. So then we would have 5 root 3 minus 2 root 15 all over 3, and that can be our final answer. All right, 18. Multiply by 2 plus root 7 on top and bottom, because that is the conjugate of 2 minus root 7. And our goal is to not have a radical in the denominator. All right, so then we get 4 plus 2 root 7 plus 2 root 5 plus the square root of 35. And on bottom, we get 4 minus 7, because this would multiply as 4. This would be negative square root of 49, or just negative 7. So then we have all of this. Nothing simplifies, nothing combines. So we just have all of that over negative 3. I'm okay with you leaving it like this. I think Math Excel is okay with you leaving it like that. If you do one and you have a negative on bottom and it tells you that you're wrong, try changing the sign of everything on top and making it a positive on the denominator. Sometimes they care about things like that, but they really shouldn't. All right, I believe that's all for P4. Yep, so make sure that you are getting those assignments completed. Remember that you have to show work in an organized manner where I can follow it. um, to turn in for some points as well. As always, ask questions if you don't understand something.